Hello students, welcome back to another episode of Principles of Micro. Today we are in Chapter 9 looking at perfect competition. We defined perfect competition in the previous episode. Now we'll look at how firms maximize profit. So the profit maximizing rule is always going to be marginal revenue equals marginal cost. We had this abbreviation last chapter where we had MC for marginal cost. We drew some marginal cost curves. Marginal revenue is going to be MR. So we said marginal costs in chapter 8 were how do your costs change when you produce one extra unit. Similarly, marginal revenue is going to be how does your total revenue change when you produce one extra unit. Both those definitions are approximate. If you want to see a more precise version, that'll be in intermediate micro. Now, I won't go through a formal proof that you have to have marginal revenue equals marginal cost to maximize profit. That's another thing reserved for intermediate micro. I will, however, argue that's the profit maximizing rule and give you some reasoning for why it's true. So let's consider the other possibilities. So either marginal revenue equals marginal cost or one is bigger than the other. So let's say that marginal revenue were bigger than marginal cost. Let's say I'm making widgets. So the marginal revenue is 10. That means if I make one more widget, my revenues go up by $10. If my marginal costs are 7, what that means in plain English is that to make one more widget, it's going to cost me another $7. So if I go ahead and make that extra widget, that means that I get $10 more of revenue, I lose $7 of cost. That means overall my profit goes up by 3. 10 minus 7 is 3. This brings us to a very important idea. If it's possible to improve your profit, that means that your old profit was not being maximized. Just think about that for a moment and you'll see it makes sense. So if your profit really were being maximized, that means that your profit is as big as it could possibly be. And if it really were as big as possible, it should be impossible to improve upon it. We just showed, though, that you can improve your profit. That means what you're doing before could not have been the best. So whenever you have marginal revenue bigger than marginal cost, you can improve your profit by making more stuff. So that means that you can't have this be true when you're profit maximizing. So as far as maximizing profit, you can just rule out that first case. You can't have MR bigger than MC. Now with some similar reasoning, let's rule out the other big possibility. Let's rule out MR less than MC. So what would MR less than MC, marginal revenue below marginal cost, what could that look like? One example, it could be maybe marginal revenue is $20 and marginal costs are 30. So let's say you produce one widget less than you are right now. You cut back on production. Because marginal revenue is 20, if you produce and you sell one less widget, that means your revenue goes down by $20. That might sound like a bad idea, but you can't judge based on revenue alone. You also have to think about costs. Our marginal costs are 30. That means if I cut back on production and make one less widget, I'm saving myself $30 in the form of lower costs. So I'm getting $20 less in revenue, but then I'm saving $30 in lower costs. overall, my profit's going up by $10. So I can improve my profit. I can raise my profit by slashing production. Now I go back to the same idea as before. If it's possible to raise your profit, then your old plan must not have been the best. So that means whenever you have MR less than MC, you can always raise your profit by cutting back on production. That means that profit maximization can't have this be true. So if we can't have that, and we also can't have MR bigger than MC, the only possibility for the firm to maximize profit would be that marginal revenue equals marginal cost. So that's some intuition for why MR equals MC is the firm's profit maximizing rule. You have to have marginal revenue equal marginal cost if you're maximizing profit. Again, if you want to see a formal proof, you might see that in intermediate micro. Now, in a special case of perfect competition, there is another form of the profit maximizing rule. So MR equals MC is true for all firms in all industries, but there's a special rule that is true for perfect competition only. So we said with perfect competition, one of our conditions was that the firm has to be a price taker. By that we meant the firm is just too small on its own to have any impact on price. So market demand might look like this. You have a large number of consumers and a large number of firms. Demand slopes downward. That's because of the law of demand. We said that back in chapter 3. Law of demand is something that is super important. If things get more expensive, people buy less of them. That gives you this downward slope. So that's what demand looks like for the entire market. However, if you're as one tiny firm out there, and there are things like 50,000 units being produced or something ridiculous like that, it's not going to matter a whole lot if you produce 2 or if you produce 8. That extra 6 units is just not big enough to have a real impact on price, have a real impact on overall demand. So for your individual firm, it's just so small that they can't influence price, demand looks more like this. You got to take that prevailing market price of 5 as given, and that's not going to be affected by how much or how little you produce because you're just too small to really be relevant. So here's what that's going to mean for us. If a perfectly competitive firm changes its quantity from, say, 2 to 6 or something like that, that does not affect the price. So what happens is that if you produce an extra unit for $5 and you sell it, that gets you an extra $5 of revenue. So your change in revenue, your marginal revenue, is going to be exactly the same as the price. So if you just combine, we said that marginal revenue equals marginal cost, and we're also saying that price equals marginal revenue. If you sub that in, that gives you this very important condition, price equals marginal cost. Now, to be clear, price equals marginal cost only works for perfect competition. With other markets, like say monopolies, now the firm can influence price. So the firm starts changing production, then price also changes. So it's no longer true that price equals marginal revenue for monopolies or other large firms. So this applies to perfect competition, but does not apply to monopolies or oligopolies or stuff like that. We'll learn about what they do in future chapters. So for perfect competition, price equals marginal cost. So here's an exercise for you guys. Let's say the price is 50, and your mission is to fill in the rest of this table. Once you have that, figure out how much stuff should the firm make, and then find out what their profit is. So go ahead and pause the video here and work through that exercise. When you think you have the answer, press play. Alright, so I'll assume you've given this some thought. So the first thing we do is just fill in that marginal revenue column. We said that under preferred competition, the firm can't influence the price. If the market price is 50, then the firm can't change that. And we said that for preferred competition, price equaled marginal revenue, so just put 50 down there for all of those values. So that fills in that column. Now we have to figure out where should the firm produce? How many units should they make? We look at where does price equal marginal cost, because that's our profit maximizing rule. And it turns out that when Q equals 2, marginal cost and price are the same. Price is 50, marginal cost is 50. So the firm should produce 2 units. The last part of the problem is that we have to figure out what is the firm's profit. So let's fill in the rest of the total cost column. We said total cost for 300 when quantity was 0, so that must be the firm's fixed costs. Because marginal costs are 40 for the first unit, that means that the firm's costs go up by 40 when they make that first unit. 340 is 340. The marginal costs were 50 for the second unit. That means the firm's total costs go up by 50 when they make unit number 2. So 340 plus 50 is 390. That's where that number is coming from. Lastly, marginal costs were 70 for the third unit. That means that our total costs rise by 70. 390 plus 70 is 460. Alright, we figure out total cost. The last part is total revenue. Total revenue is just price times quantity. Or equivalently, you could just add together all the marginal revenues. So total revenue is 0 when you produce 0 units. If you're not making anything, you're not selling anything, which means no revenue. If you produce 1 unit and you sell for the market price of 50, you get $50. If you have 2 units, you sell them for $50 each. 50 times 2 is 100. Likewise, if you have 3 units, 50 times 3 is 150. And I said equivalently, you could just use marginal revenue. If total revenue is 0 when you have 0, and your revenue rises by 50 when you produce 1 unit, 0 plus 50 is 50. 50 plus 50 is 100. 100 plus 50 is 150. So our table is complete. We established earlier that the firm should produce 2 units. That's where price, 50, equaled marginal cost. And that maximized profit. So how big is their profit when they produce 2 units? Well, their revenue is 100. Their costs are 390. 100 minus 390 comes out to negative 290. So the firm is losing money, but it's still best to produce 2 units. If the firm were to shut down and produce nothing at all, that'd actually be worse. If you produce nothing, you still pay your fixed costs. You're still paying rent on your storefront for $300, but you're getting no revenue, so that's negative 300. So producing 2 units is the best choice, even though profits are negative. Alright, here's another example so you guys can get some extra practice. Market price is 100, and we have to accept the market price as given. Fill in the rest of the table and figure out how much stuff should the firm make, and also find their profit when they're maximizing it. So pause the video here while you work through that exercise. Alright, I'll assume you have given this some thought. So we can fill in the marginal cost column by looking at how do total costs change as you produce more. Marginal costs are the increase in your total cost when you produce one extra unit. If your total costs go up from 130 to 180, that means they've gone up by 50. Marginal cost of the first unit is 50. 130 and 50 is 180. When you make a second unit, your total costs rise to 270. 250. That is $70 higher than they were before, so marginal cost there is 70. 180 plus 70 is 250. Lastly, when you produce a third unit, now your total costs are 350. If costs have risen from 250 to 350, that's an increase of $100. So MC is going to be 100. That's marginal costs. Marginal revenue is always going to be the price if you have perfect competition. Price is 100, so just put 100 down there and all those cells in the table. Total revenue is going to be 0 when you produce nothing, so you put a 0 up here. For total revenue, you can find that in either one of two ways. You could just do price times quantity. So 1 times 100 is 100. 2 times 100 is 200. 3 times 100 is 300. Alternatively, you could just add together the marginal revenues. 0 plus 100 is 100. 100 plus 100 is 200. 200 plus 100 is 300. They both work. They both give you the same answer every time. So to find out what the firm should do, we got to use our profit maximizing rule. We look at where does price equal marginal cost. So price is 100, whereas marginal cost equal to 100, that's going to be over here. That means the firm should produce 3 units. Last part of the problem, let's calculate the firm's profit when they produce 3. So their revenue is going to be 300. Their costs are 350. 300 minus 350 is negative 50. So this firm is also making a loss when they are producing optimally. So profit's not always positive. That's one lesson you're getting from this. Firms can make a loss. So you can also look at the firm's profit or loss graphically. So here are some of the curves we talked about in the previous chapter. So MC is the marginal cost curve shown here in gold. ATC in blue, that's the average total cost curve. The prices will be just a flat line shown here in green. Recall, if you have perfect competition, the firm can't influence the market price, so no matter how much or how little they produce, the price is still going to be 60. So price is the firm's revenue per unit. How much money they make every time they sell a widget. Average total cost is the average cost per unit, the average cost of making another widget. So the gap between price and average total cost is profit per unit. So you're making this many units, looks like about roughly 9.5. If you're making roughly 9.5 units, then your revenue per unit's up here, at this black dot. Your cost per unit is where that would fall on the blue line, average total costs. So this distance here is your profit per unit. You then multiply your profit per unit by how many units you're making. That would be this length over here. That gives you a rectangle that's equal to your total profit. So what's so special about this point? Why that point get a black dot? Well, that comes from our profit maximizing rule. We said you have to have price equal to marginal cost to maximize profit. We saw earlier how to do that with math. Now we're seeing how to do it with a graph. So graphically, price equals marginal cost means that marginal cost curve is meeting that price line. And that happens right over here. That's why I got that black dot. So that's how I know the firm's going to make this many units, about 9.5. And with that information, we would find their profit being this shaded rectangle. Now you might have noticed in that graph, there's actually 2 points where price equals marginal cost. I was talking about this one over here, but there's another point back here that also satisfies that rule, price equals marginal cost. So why did I focus on this one and just ignore the other one over there? So it turns out that there's an extra part of our rule. You have to have price equals marginal cost, and you also have to have marginal costs increasing. You have to have an upward slope for the MC curve in order to maximize profit. This is another one of those things you just have to trust me on. I could prove it. I know how to prove it, but that proof involves calculus. Once again, calculus is not a prereq for this class. If you're taking intermediate micro, they might show a proof of this result. So again, just have to trust me on this one. So yeah, price equals marginal cost for 2 different points here, this one and that one. But the MC curve is sloping downward for this first point. So this first point does not maximize profit. Only this point over here is profit maximizing. That means the firm is going to want to focus on this point. So that's how the firm would maximize profit if they choose to produce. Now in some cases though, it's better for the firm to shut down. Sometimes producing 0 and just paying your fixed costs like your rent is better than producing. Now let's just revisiting the example we had earlier. We established that in this example the firm should produce 2 units and that maximizes their profit even though profit is still negative at minus 290. We said if they shut down entirely and produce nothing, then their profit would be negative 300. That's even worse. So the firm doesn't always shut down just because their profits are negative. There is a special shutdown rule that tells you when they should do that. So here's our shutdown rule. You want to shut down if the price is lower than average variable costs. And there's some intuition for that. So the firm should actually not really think about its fixed costs in the short run. That's because fixed costs, by definition, can't be changed in the short run. You still got to pay your rent no matter what. That means the firm is going to focus on its variable costs when it's thinking about short-term decisions. So the price is how much money the firm makes on each unit on average. The average variable cost is the variable cost per unit. Now if that average variable cost is bigger than price, that means that every time you produce a unit, then you're just losing more and more money. So if I'm making $7 per unit, but my variable costs on average are $8 per unit, then every time I produce another good, my profit goes down by $1. If I keep producing more and more and more, my profit's going to keep getting worse and worse and worse. So in this case, production just makes things even worse than they were before. It's better to just shut down and produce nothing and only have your fixed costs. Trying to produce your way out to profitability will actually just make things worse rather than better. So that's our short run shutdown rule. shut down if price is less than AVC. So here's a graph with some cost curves. So the marginal cost here is shown in green. The ATC curve is in blue, that's average total cost. AVC in gold is the average variable costs. So this graph is not entirely arbitrary. Remember that I said back in chapter 8 that the marginal cost curve always intersects average total costs at the point where average total costs are minimized. The same is true for average variable costs. Average variable costs are minimized at this point over here, where the MC curve crosses over. So we'll think about different scenarios and figure out if the firm would be willing to shut down or not. Let's say the price is 10, shown by this line down here. In that case, price is always below average variable cost. When price is below average variable cost, the firm should shut down. So the price is down here, the firm's going to shut down and just not produce anything. Still got to pay your rent, but at least you won't get deeper into debt by producing things and making your profits even lower. Now what if price were 60? So if price were 60, we first figure out what the firm would do based on our price equals marginal cost rule. So if price is 60, marginal cost is here in green, so the firm should produce over here. Once again, there are 2 points where price equals marginal cost. There's this point out here, and there's also this one back here. However, we said that you need to have the MC curve be sloping upward to maximize profits, so you'd only use this point over here. So the firm could consider making this much. They're making it around, looks like roughly 9 units. So the firm makes 9 units and price is 60. What's the average variable cost for making 9 units? You go down here to your average variable cost curve, and that'd be around there. So in that case, your average variable cost for making those 9 units is below the price. So in that case, the firm would not want to shut down. The firm should produce about 9 units when the price is 60. So stay open when the price is 60, shut down when the price is 10. That's your big conclusion. So now we can derive the firm's supply curve. So the supply curve is, for the most part, going to be equal to the marginal cost curve. If the price were 100, you want to produce where price equals marginal cost, so that'd be right over here. You produce at that exact point right there. So that point becomes on your supply curve. If price were 80, you look at where is price equal marginal cost. That's right over here. You produce at that point, quite around 10. So you put that point also on your supply curve. So so far, supply curve is the same as the marginal cost curve. The same is true for price equals 60. Price equal marginal cost happens right over here. So you put that much production in your store, and you do that for your supply curve. And same for price equals 40, and so on. Now when price starts getting low, like price being like 10, then things change. When price is 10, now price has fallen below average variable cost. We said the firm shuts down if price is below average variable cost. So here's a price of 10, and there's your average variable cost here in gold. So if price is below average variable cost, you want to shut down. Shutting down means the firm produces nothing, so Q abruptly goes to 0 if price gets too low. So the firm shuts down around a price of 20. You can see here on our graph that once price gets around 20, that's when it gets to be below average variable cost. So the minimum average variable cost would be around here, and that's around a price of 20. So notably, this goes back to a point I made earlier in chapter 8. I said that you could be tempted to think that the firm should always produce where its total costs are minimized or where its average variable costs are minimized. And that's not necessarily true. You can see over here, if price is 80, you want to produce at this point, not at that point. So you don't want to just minimize average cost. You got to think about revenue as well. And the way you think about it is by using that price equals marginal cost rule. That's the rule that maximizes the firm's profit. So that wraps up our section on short run for profit maximization. Be sure to tune in for our next episode and learn about how to maximize profit in the long run.